Hello everyone, I'm Tanuja Kopal, Contributing Editor for Lab Manager, and thank you for taking the time to join us for our Product Spotlight webinar hosted by Lab Manager in partnership with Waters Corporation. Today we have Heather Longden, Senior Marketing Manager for Informatics and Regulatory Compliance from Waters, talking about what it takes to really deploy an enterprise chromatography data system in your lab. Heather is a specialist in compliance to e-record regulations, acting as a resource to the global informatics community at Waters and the users of all Waters informatics products. She helps design compliance into Waters informatics products and services, keeps up to date on the latest interpretations and amendments to the regulations, and also passes along information to the Waters field and corporate organizations. And I'm really glad she's here to share some of her knowledge and expertise with us today. But as Heather is going over her talk, I'm sure some questions will pop into mind. There might be some issues that you are grappling with in your lab. And if you want to bring it up, please type it into the question box that appears on the left-hand side of your screen. All you have to do is hit submit, and I will be happy to go over your questions and comments, and they are really anonymous, so feel free to share your thoughts with us. We really like to keep things very interactive, and we'll go over all your questions and comments after Heather is done with her talk. Also wanted to remind all of you that the webinar will be archived on Lab Manager's website, and you will be sent the link to that archive in a couple of days. You can go back and review the webinar, and you can also forward it along to colleagues who you think may be interested in this topic. But please note that you will not be able to download any slides from the archive. We will share with you Heather's email address at the end of the webinar, and you can definitely follow up with her if you have additional questions or if you need a copy of her slides. The webinar platform that you see is also very user-friendly. You can move the boxes around. You can expand the slide window if you have trouble viewing the text. There is also a resource widget, and we have some resources from Waters that we have downloaded there. So that is something you can open up, and you can take a look at the documents that are located in that resource widget. And that resource widget can be opened separately from the slide window. So you can have access to both at the same time. So with all that information at your disposal, let me now welcome Heather. Heather, nice to have you today, and looking forward to hearing what you have to say.
Thank you very much, Tanuja. I hope everybody can hear me okay. Please feel free, if you have issues, to let the team know through the chat window. As Tanuja said, my name's Heather Longden, and what I want to talk about today is really to share some experience about working with customers, chromatography customers, for about 20 years as we've gone through a series of challenges related to data integrity. The regulatory bodies are very keen to ensure that the data we present is trustworthy. And the purpose of this talk is really to discuss what does that mean. My role at Waters is really to be an interface between organizations such as the regulatory bodies, through a lot of the time industry groups such as ISP, E or GAMP, and also talking to a lot of our customers, both the users of the chromatography systems in the lab and the QA departments, for which they have a very real responsibility in ensuring the data is trustworthy. That information I bring back into Waters in order to train our sales and specialists to be able to help our customers in the best way and provide professional services along the lines of validation or training or simply just consultancy advice. But my main role here is to bring that knowledge to make sure our products have the required functionality and design that allows our customers to be able to work under that regulatory framework. At the moment, there's a very big push within the regulatory authorities to actually look at compliance and quality in a slightly different way. Traditionally, people have looked at the regulatory oversight as a culture of compliance, whereby while an inspector there or while a QA person is looking over your work, you need to be able to demonstrate that you're working according to the required regulations. But really, this quote by Henry Ford says a lot more, which embodies what the purpose of a regulatory body or a QA department is. And that means ensuring a culture where people are doing the right thing even when nobody is looking. A lot of that comes down to management oversight and direction, but also empowerment of the analyst to know what the right thing is and to make sure that in generating results, they are doing that in the correct way. This excerpt from the RAPS website actually summarizes, though, that there have been a whole bunch of recent warning letters where the integrity of data, and in a number of cases very specifically chromatography data, has been called into question. And you can see that these are very closely being issued very closely together. And there is quite a big movement now to see what is behind these warning letters, to understand what the regulators have concerns about, and ensure that in all the laboratories we've addressed those risks and have procedures in place to make sure that those particular concerns are not a risk in each of our own laboratories. So part of what I will do is looking at the feedback from those regulatory observations and try to get to the root cause of what is concerning them. Overall, most regulatory bodies are concerned about quality issues to ensure that the products that are being supplied to the public are safe, but more importantly, that any concerns about production don't lead to drug shortages where there are people whose health and lives are dependent on the availability as well as the quality of the drugs that they're taking. The FDA do publish in a number of different ways their observations in order to better educate the entire market. And one of those is through something called the Turbo database, which is available on the FDA.gov website. Here they will provide a summary of the 483 observations that their investigators have observed over the past year. And if we look at the top 9 citations in that list, 3 of those are around SOPs, which are either not established or not followed correctly. So it demonstrates that it's very clear that despite whatever instrumentation or software or any other equipment that you have, it's how you use it and how the SOPs are followed, which is very important. But you'll also see in this top 9 scientifically sound lab controls, which for our chromatography customers is something they need to make sure is been addressed and are being followed in their lab. A couple of other things that may be of importance in a chromatography lab are that calibration and inspection and check-in of all the instrumentation is done correctly to ensure its continued performance, and that when there are out of specification results or any other discrepancies or abnormal results, that these are investigated in a proper way. The FDA provides guidance exactly on how you should do that in a laboratory environment, and very often those procedures are either not followed at all or not followed sufficiently well. Looking globally, we can find similar information about European inspections in a database that is available on the EUDRA website. We've always been able to see which inspections have been successful and a GMP certificate has been issued. But they also recently opened a database of non-compliance reports, or sometimes called statements of non-compliance, which gives us in the wider world looking to see examples of the kind of observations that an inspector does not want to find when they're actually in a laboratory. And unfortunately, when I've looked through this database recently, I'm seeing very similar trends from European inspectors than what I'm seeing through the warning letters, which includes things like deliberate falsification of results or hiding the non-conformities. So rather than properly investigating why a particular result appears to be incorrect or appears to have issues, it's been simply ignored or deleted and the results are being repeated in order to try to get a correct result. This leads into a question about the review process and the control of computerized systems, which would allow this kind of behavior to happen. Other concerns from the European regulators include qualification of equipment, but also inadequate records, some concerns about specificity of methods, and unknown peaks in chromatograms. So let's have a quick look at what the FDA observations are, and included in them the current trends that are found in that EUDRA database. And you can see here, this is simply extracts from a number of documents through the last 2 years. Some of the technical controls that the inspectors have uncovered is that there has been sharing of accounts, and this is something which has been noted over many years, and most people do understand that individual accounts is absolutely critical for attributability of any records that are created. But in many cases, usernames and passwords are shared, and the last quote here said the analyst misused the administrator password to delete and overwrite data. I think looking at the privileges that users have been assigned to their accounts is absolutely key just at the moment with these concerns about data integrity. Another control is, do you keep all the electronic records? And there have been a number of comments here in those recent warning letters that data was not available, only printed copies of data was available, or data was missing. So what does that really mean? What does the question arise in investigators' head when they see that data is unsecured or accounts are being shared? When they investigate further, they uncover that a number of files have been deleted or could be deleted. If you look at this list of observations, some cases it just says the users are able to delete data. Raw data files can be deleted. But in other cases, you can see that it says the HPLC actually showed us that data was deleted, or our inspectors found a number of deleted chromatograms. How did they find that data? It was through the audit trails that had been built into whichever software was being used, which clearly recorded that users were deleting data. And the concern, if you look at the very last point, is that samples may be being repeated, and then that evidence, those electronic records, are no longer available for review. When the next question was asked about why the data was deleted, it came to light that it seemed to be failing injections or unofficial testing of samples where the results probably were not as expected, or maybe had some issues, or there was an error made in the laboratory, and that this unofficial testing appeared to be a much more widespread than anybody could have thought. And when we looked through this, we found that although the samples did have final results that were reported, there was often trial testing of those samples in a different location, or by being deleted afterwards, being omitted from the final reporting of the data. And the regulators are very concerned with this. They look at this as it may be malicious to hide failed results or to mask poor quality data, but it may just be poor practice. And unfortunately, without the data to be able to investigate that, the suspicion falls onto poor quality product, which may be entirely not true. Now, the QA or the manager or peer review process is designed to uncover practices which don't follow the SOPs that have been put into a laboratory. And there have been comments in the warning letters that said all electronic data should be investigated using audit trail capabilities. What they've also found occasionally is that some of those audit trail capabilities have been possibly deliberately switched off, or maybe just unknowingly switched off, which is removing a whole swathe of very useful information that a QA or manager should be looking at as part of a data review to authenticate it. As we look further through the current list of audit trails, we can find very specific reference to why the QA or manager review of that data is absolutely critical. And it includes looking at the complete records, whether those records have passed, but also including records and results that have failed, because those failed results would justify any repeat analysis that may have been required by the laboratory. Unfortunately, it appears to come to light that in some laboratories, it seems to be easier and simpler to ignore the failed analyses and simply repeat the runs until good results are obtained, and only present those good results to the QA department. Of particular concern to some of the investigators is how they were able to uncover either omission of data or malicious manipulation of the data in a couple of day investigation, where the QA unit, who is on site all time and has that as their major responsibility in the organization, are unable to find the errors. And I think the problem has been that very many review processes rely on paper review. They rely on printouts and a paper data package from which it's very easy to omit any results that looked suspicious or had errors involved in it. Only by going back to the original contemporaneous electronic data can any manager or reviewer be sure that this was the only analysis of a particular sample in the laboratory. When we're using computer systems, the computer system validation process is very essential. And there have been citations in the warning letters about verification of access controls in particular to ensure that users don't have the ability to delete results that they don't wish to be reviewed. Computer system validation is designed to challenge systems, to challenge the procedural controls, the administrative controls, and the technical controls that the software provides, that they're in place and configured. And one aspect of this really is around that delete privilege. It should be that everybody in the laboratory who is responsible for producing results should not be allowed to delete data, and that's very easily controlled in almost every piece of software by privileges. However, I would advise that it's really useful to be able to document evidence that a particular user or a particular number of users, when they try to delete data, it would not be possible. So proper computer system validation would highlight any incorrect configuration of the users, whether people have too many privileges for the roles that they have to perform, which would give them opportunities for that malbehavior, and would identify any areas of risk in the software where data may be deleted or where data manipulation could occur undetected. So let's look at the theory of why we're talking about electronic records and data integrity, and what does that really mean, and how does that translate into the laboratory. The purpose of the electronic record policies, which in the US, or for anybody importing to the US or exporting to the US, is 21 CFR Part 11, was to ensure that everybody could use and trust electronic data in the same way as traditionally they had done for paper data and paper records. To ensure that data integrity, they said the record should be created contemporaneously with the analyses, in our case. They should be retained, and they should be reliable, and any changes should be very obvious. Where we are using computer systems, they should be validated to their intended use, such that there's no decrease in product quality or quality assurance. And evidence of both of these should be available to show that before the system was put into use, they had these things had been considered. The issue has come about now that the regulators actually believe the electronic data is more secure than the paper records that they replaced. So I'm going to walk through a number of what I've called myths about chromatography systems and data integrity. These are really my view on a number of questions that I've been asked, and my personal view about why I think they could be addressed or how they could be addressed. I'm going to talk about electronic data and its use versus paper data. I know a number of companies are still defining paper as their raw data and don't believe that data integrity is an issue. I'm going to talk about test injections or single injections and the role of those tests, and again, my belief that these are absolutely good scientific laboratory controls. And then we're going to talk about the occurrence of multiple results or injections and what they imply, how people are looking at those, and maybe coming up with some concerns and controls that potentially are really not good scientific practice. We'll look at how you might review reports with audit trails and what the alternatives are. And then I'm going to just briefly talk about if I have concerns about data integrity in my chromatography lab, can I fix it by just buying a new piece of software? And then if I do buy a new solution for my laboratory, what's the role of the vendors in validating that? Should the vendors not do that validation for me? We'll begin with the data integrity and paper issue. Obviously, the regulators believe that data integrity is key, and for so long they have just been taking at face value any data that's presented to them. As I mentioned, the FDA are now very concerned that printed chromatograms cannot be designated as raw data. All the regulators are concerned about reviewing audit trails because Annex 11, the European regulation, actually stipulated that. And most of the regulators, the FDA and MHRA amongst them, have a real focus now on this, which includes a lot of continual training. And they will expect to look at the electronic data and not just the printouts. A number of FDA investigators have actually stood at conferences and said, if the data looks perfect, then I really don't believe it. I want to ensure that we can see the data with errors in it as well as the good data is available. And when we talk about out of specification or abnormal result investigation, really getting to the root cause of that is critical. And just putting it down to human error without examining why a human made an error is something that the regulators are very keen we all do. This is an excerpt from the FDA.gov website. They have a number of question and answers, level 2 guidance pages, and there is one there on records and reports. And for a number of years, they have had a question on there which very clearly said that for chromatography data systems, the associated printed chromatograms that are used do not satisfy the predicate rule requirements according to 21 CFR 211, which is the predicate rule for GMP. There's a very long answer in there, which I encourage you all to go and look at, but it does say the electronic record must be maintained and readily available for review by, for example, your own QA people, the managers, or the FDA investigator. And I'm very keen that we build this electronic review into the normal data approval process in a laboratory to avoid the first person who ever looks at the electronic record being the FDA investigator. I work a lot with the ISP organization, who have a data integrity special interest group running at the moment, looking at concerns about data integrity. And this was a term, what does data integrity really mean? It's called the Alcoa Plus. And so originally, it was defined as data that can be trusted as attributable, legible, contemporaneous, original, and accurate. A colleague of mine then also added 4 other terms which he thought were missing from that definition, which is complete, consistent, enduring, and available. And that's why it's Alcoa Plus. I believe, from my interpretation of the warning letters and observations, that the current issues, although they talk about issues with attributability and with contemporaneous recording of data, it's mostly about the term complete. That not all of the data that's presented is great, but not all the data is being shown. And I think that relying on analysts to print out a specific set of records for batch review on paper gives the opportunity to not include all the data around repeats or reanalysis, if it suits. The second myth here, I think, is about test injections or individual injections. We had a number of requests from our users to limit the use or the permission to use single injections. And digging into this, we realized that they were particularly called out in some of the warning letters, and I believe that call out was erroneous. All of our chromatography experience here at Waters says that running any chromatography system where you're going to collect data without first verifying the system has been properly equilibrated and is capable of performing as required is poor practice. And the USP 621 chapter holds that up as well. If chromatography systems, columns, and mobile phases worked as soon as you at optimum performance as soon as you switch them on, this wouldn't be an issue. But there's still a certain amount of magic in chromatography. The system needs to equilibrate together. Test injections, as we've traditionally used them, of an independent solution provide assurance that the system is ready. If it's not, a further equilibration time may be required, and then the test injection is repeated to verify that the column can be used for proper separations and get valid results. However, the term test injections and the term did it pass or fail is what's causing particularly some issues. So we're proposing that a better term for these test injections is system readiness checks. And in trying to explain that this is not pre-testing my results to preview what the answer will be before I commit to them, I was trying to think of a good analogy. With a chromatograph, you're only going to get the correct results if you prepare the system. And starting the real work, doing my first injections of my replica before I know the system is ready, I believe is foolish. And there is an analogy for this, which is when you're making a pancake or a crepe or a dosa. I can be very good at putting the temperature on, leaving for 10 minutes, putting the oil in at exactly the right time. But that very first pancake or crepe or dosa is always a test. It doesn't predict the success of what the later ones will turn out, but in fact, it's the only way I can know the system is really ready to use. And with chromatography, it's kind of similar. So I think we do need to be sure in our laboratories that we allow the use of system readiness checks, whether those are single injections or little small sequences of 4 or 5 that we just put on to see how they work. It definitely should never be the samples that we're intending to analyze. And I think the concerns that I read into the warning letters and observations is that the samples that were going to be run in the batch were being used or being designated as test injections. And this really adds to the concern. Even the possibility of using standards needs to be considered, because if you have strict criteria around standard injections during your run, you want to be sure that you're not previewing those by using your test injections. So an independent solution is much better concern. In the bioanalytical world, they have come to a conclusion that a pooled sample gives them a real mimic of the samples they're going to run without any concerns about unofficial testing of samples later. I don't believe that these test injections, these system readiness checks, have any place in a batch report, but I also don't see any need to delete or hide them. They can be available for use if somebody wants to see them, but the quality of those test injections really doesn't affect what the subsequent batch performance for the samples may be. It's a prediction of whether the system is performing and suitable for use. During the batch, you will also run system suitability samples anyway, which will further highlight that the system continues to be suitable for use. And that's normal to have that as part of the sample set or the result set. But in your SOP, if you're writing and thinking about this, if you do have system suitability at the beginning of the run and in the sample set, you need to be very clear about what the correct procedure are if the analyst notes those things fail before the batch is completed, about whether to continue or repeat. Now we'll look at the multiple results or injections which could indicate the lab is cheating results. Errors must be concealed, repeat injections should be hidden, repeatedly processing the data should be avoided, never change the algorithm, and you should never do manual integration. So I have a number of views on where this may be sending people in the wrong direction to ensure data integrity. Bob McDowell, a number of years ago, wrote a paper called Fat-Fingered Falsification or Fraud. And he acknowledged that mistakes happen in every laboratory. We aren't all perfect, and any lab that shows perfect results 100% of the time is probably hiding something. But he said the peer review process is designed to check for mistakes and errors, provide a way to correct those, and calculate results correctly. And as long as those changes and updates and reprocessing are done transparently and with justification, there should be no issue. However, when we get to falsification of data, and generally in Bob's paper he talks about that being backdating of signatures, things that just one person has done to try to maybe gloss over a small mistake in the laboratory, that it should be made very obvious in a company that this is behavior that's not tolerated, that QA should have some action, and there should maybe be a CAPA to look at how to avoid, look at the impact of that kind of behavior and how to avoid in the future. Where the regulators are concerned really is about the next step up, where deliberate fraud in a laboratory, colluding between multiple people, maybe managers and staff, is taking poor quality results and giving them passing results and putting those products into the market. What the regulators are trying to do when they're looking at systems is to see how you deal with mistakes, how you deal with falsification or non-contemporaneous recording of data, such that if there was any kind of fraud in the laboratory, you would find out and be able to correct that before whole product went onto the market. Now, when there is a failure in the lab, there's various ways that people react to that. And a lot of this is about the cultural aspect that all of the regulatory bodies and the industry bodies are very concerned about addressing at the moment. That most people have a view that mistakes are something to be punished, and if it's possible, to hide them from the management. Additionally, if there are errors, and various blame is put onto software or instruments or analysts or quality, which may be not correct. And this is why the investigation of out-of-spec results is so key. But also the investigation, there's often pressure, if there is an OOS investigation, to make that a very onerous process, in which case I haven't got time to do the investigation. It would be much easier if I just swept these results under the carpet. And addressing that concern is something almost all of our customers today are looking at to say, I think we need to address it. So currently in chromatography, hiding the evidence from previous injections, data that's too good to be true, where there's never been any out-specification result, and looking at the data integrity controls is something that I think everybody who wants to ensure that their CDS laboratory is not at risk of any of these behaviours should be looking at. Now, some of the regulators are being trained that if there are multiple results, it indicates that users are trying to integrate results into acceptance. I believe that this conclusion is driving poor behaviour and actually driving people to hide results. I believe you can only conclude that you're reintegrating into acceptance by looking at the audit trails and the actual integration, with documentation about why. Many times I've heard people in the laboratory say, I must only process this once, otherwise I'm going to be in trouble. And that leads them to work in ways that probably are not transparent. So if I do process data 3 times or I inject it 3 times, all of that evidence, all that data should be available for review. What is the right integration should be defined through SOPs and training, and for every method that may be different. Now this is a screenshot from Empower Software, I apologize, but that's what I have access to, which shows where there was 3 results created for a particular injection. It may be a little difficult, but there's a result ID column which clearly identifies 3 versions of the results, and there's a result comments column where I put in the reason for the reintegration of the data. The bottom table shows me the differences between those 3 results. Now in this case, you may be able to see in the column called integration type some capital letters and then some small letters, which indicate manual integration. There's also ticks. And in this case, I really was deliberately trying to integrate something into compliance. But that same result could come about purely by optimizing the integration to get correct integration. And I can't really tell that unless I open up and review each of those result versions. So if I looked at this one and said it failed and saw that it failed specification, maybe there really was an error in the batch. But I can't see how that changed, unless I look at all 4 results. Oh, I beg your pardon. So if I look at all 4 results, then I can make a decision about whether the integration was being done to hunt for the right result, or if it was actually not very good in the first injection and I was reintegrating to improve the integration according to the SOP and definition. Using the latest integration algorithms will also help the users in the lab to get integration right first time and reduce the need for manual interpretation of the data. My view on integration and algorithms is that the chromatographer actually knows what the right integration of any particular peak is. We use the automated algorithm to try to do it faster and in a more automated manner. And when we have base result peaks, this is easier, but also if we use the latest algorithms. But actually, somebody reviewing the integration is going to tell you whether the integration was correct or not. So when we're looking at processing data, thinking about processing batches together, thinking about not forcing a right first time integration rules, and demonstrating in the methods what integration should look like is much more valuable than defining exactly what the parameters for integration should be or which method should be used. We'll look at reviewing data and paper reports. The Annex 11 says we need to look at reviewers' audit trails, and most of our customers are struggling to come up with a good SOP at the moment, which meets the needs to look at some audit trails as part of data review and look at other audit trails as potentially part of periodic review, system-level activity, that kind of thing, which doesn't affect day-to-day data. Inspectors will look at them, so be sure that you're aware of what is in them. And one of our major concerns is that audit trails in some systems are really defined as a log of everything in order to comply with regulations and not designed for review. So there's two options really: to print them and include all data relevant audit trails on the regular reports and then sign them. Or if you have tools in the CDS, I believe that a forensic review of audit trails electronically, following a clear SOP about which particular ones need to look at, and then signing the result to say I have done that electronic review is much more valuable. It is possible with most systems to have some kind of indication on the report about the number of times data was processed, if it was manually integrated and this kind of thing, which may be an indicator of which audit trails need to be examined. You can also look at the sample history for every single sample that's run. However, you will find most software, Empower included, has a kind of a review tool, conveniently called Review, that allows you to look at a result and track back to anything of interest that you want to confirm, such as the method or the processing parameters or the calibration curve. And Empower now has the ability to track from this window direct audit trails as well. So there's a result audit viewer included, that if I ever have a concern about a particular result, I can simply click one button and get to the audit trails for that result in one convenient location. This is only available with the latest revision of Empower 3. Buying a new CDS makes you compliant. You can buy a network solution where the data is stored in one location only, and that removes the risk of people going onto local hard drives and deleting data. It certainly does reduce those kind of risks. However, when you're building the network and the landscape, do think about standalone workstations you may still have, and is there a way you can take those systems and also include them in the same location so the data is going to that single server and not being stored or processed locally. I have been into some laboratories where they decide to have one network for their regulated work and one for their unregulated work or their research work. This has some concerns, is that it provides a location where users might easily choose to do unofficial testing of results prior to official testing. As long as those users don't have access to both systems, this can be minimized. But having two systems in a network with different access for different purposes does pose a risk. Finally, we have a number of cases where people are using a workstation as a fail-safe for if the network goes down, I have a workstation I can use. And this is a very good solution, provided the controls of that workstation are very well defined, such that data can't be collected and processed locally when users don't want to send it to the database. Okay. Thank you. And then finally, even in a single location, designing how the projects and folders are used is really very essential to ensure that the data can be found, that any reviewer or investigator can find the data easily, and to make sure that no data is missing when they're reviewing that, either in the live system or in archives. So locking projects and making sure that only designated folders are used reduces the risk that users may create their own locations to do unofficial testing. Finally, validation. This is a very good guide for anybody who is contemplating validation of a chromatography system in a laboratory. Focus very much on laboratory computerized systems. It clearly defines the role of the vendor in blue versus the role of the regulated lab in pink. And so before we release a product, we will go through a whole lot of verification and specification for the software before it's even released. But there's still a role for specifying what will be done in the lab and verifying that the controls are set up correctly. And that verification phase could include vendor services like instrument and software qualification or verification testing, or even helping with writing very customized verification tests, either by the vendor or by a third-party consultant. So there's a whole mix of testing and challenge testing that could be done in that verification step, provided by different people, but ultimately is the responsibility of the regulated lab. This is a graph that one of our users put together where they specified the different roles and what verification could be done on their system when they installed it, some by Waters, but some by their own users or their own QA people in qualifying instruments and applications. Part of those services may be something where the vendor, such as Waters, can come and run some automated tests, particularly to focus on Part 11 requirements, which we know are very common requirements for all of our regulated customers. And that does eliminate user error in the testing and reproducibility of the testing when those automated kind of services are deployed. So in summary, what I want to show you is where I found that particular question and answer about printed chromatograms. There are a whole bunch of new questions and answers being posted by the FDA in that same place. And I know you can't read it, so I typed them out for you. So as well as the printed chromatograms and how they apply to the predicate rules, there's a question about destruction of internal quality assurance reports. There's a question and answer about how to establish expiry dates. But there is also 3 questions around the topics we've been discussing here today. Why is the FDA concerned about using shared login accounts? Can electronic signatures be used? And particularly why the FDA has objected to the practice of using samples to perform system suitability testing. And I think that very clearly reflects the interpretation that we have here at Waters, that it's not about test injections, system readiness checks, but it's about using actual samples in those tests, and particularly about using entire batches and designating those as test injections. What is a compliant chromatography system? Well, vendors provide compliance-ready solutions. Any system is not really compliant unless the people in the lab understand it, have control of the system, have access to the data, can provide evidence that the system does what it should do, can maintain that whenever changes occur, and have a suite of SOPs for use and management of the system, including the hot topic of data review, which are up to date and followed. And this reminded me of a label that I saw once in a child's costume, which said, wearing this garment, Superman outfit, does not enable you to fly. Buying a system such as Empower, which can be used in a compliant environment, doesn't automatically mean that your laboratory is compliant. These other actions need to be taken care of as well. So with that, I will hand back to Tanusha for the question and answer session. Thank you very much.
Thank you, Heather. Very, very interesting talk. Very timely, of course, because of all the issues that we have been seeing. And a number of questions have come in, so let me get to that. Some of these questions touch on issues that you have already answered, but I think given the number of questions that have come in related to that topic, it may be worth reiterating or clarifying some of the issues. I think most of the questions go back to this, the concept of trial runs, right, or unofficial tests that people perform. So let me ask those questions again, and then you can possibly clarify some of the issues even further. So when it comes to trial runs, how should they be recorded? How should they be labeled? And I guess where should they be stored?
Thank you, Tanusha. I think really it's a case for everybody to look at the practice in the lab. I believe the very first thing is to not use actual samples for those trials, or the system readiness checks, to not to be open to any concerns. I think they should definitely be kept as part of the records in case you need to go back to them. I think deleting them serves no purpose.
Right.
But I also believe that they don't belong as part of the batch record. because it may have taken some days 12 system readiness checks before the system was ready, but it doesn't actually affect the final performance of the system. So I've seen most customers will clearly label them as test injections or system readiness checks in some way. They'll store them in the same folders as the batches.
Okay.
But whether they're done through single injection or sequences, I think is really not very important. But I do think they should be clearly labeled as their purpose, and I do believe they should be available in case anybody asks for them. But I wouldn't report them routinely with the actual batch of samples, because maybe if there was an actual fault on the instrument, maybe with the system readiness injection would say, this system's not working, I'm going to go away and run on a completely different system which does perform.
No, absolutely right, and definitely worth going back and answering some of those questions. The other question is, how long do you actually keep these records, especially the electronic records? How long do you retain them?
The electronic records for a batch analysis is a critical part of the batch data, and as such, the length of time it needs to be available will be determined by the predicate rule that applies to the data. As you know, most of the data, how we look at the regulations with data is we look at the predicate rule which says you must keep a record of this data, and we'll probably tell you how long that needs to be kept. If it's electronic, then Part 11 tells you how to keep it, but how long it needs to be kept is part of the original GMP or GLP. And it's actually quite a lot shorter than many people believe, depending on which country you're in. So depending on where the product's being sold to, those data retention policies could be quite different. But for regular manufacturing data, it's traditionally 2 years past the expiry date of the last batch of product that material formed a part of that you were testing. So that's a bit complicated answer, but it's actually 2 years past the expiry date of the last batch of product that was used. So people sometimes say, I have to keep them for 10 or 15 years or 20 years. Oftentimes that's not required. However, GLP data that was used as part of submission may well be required to be much longer, and a recent change in the EU regulations did specify that kind of data probably needs to be kept for the lifetime of the marketing authorization that was issued, which could be a very long time.
Okay, that's good to know. The next issue that's brought up is actually about accessibility that users have. So one of the questions is it okay to share an account, but have certain users have a read-only access?
Okay, it's a very common question, but you can see that there was already on the FDA.gov website exactly why that regulatory authority is concerned about sharing accounts. It's to do with the data integrity term attributable. So if there's an action that you can do, data that can be changed or created or deleted, it must be very clear who the person is who has done that access. Now, if you were having a read-only account where nothing could be changed, potentially you could look at the risks of that and say, well, nothing can be changed, therefore there's no data that needs to be attributable. However, as well as the compliance aspect, you do need to take care of the software, and particularly when the database is involved, the database licensing that's associated with it. There may be other rules and regulations outside of FDA compliance which say that you must have unique usernames for people. I know Oracle have done audits sometimes on site to check that every individual user has an appropriate user account. And that's nothing to do with compliance, nothing to do with chromatography systems. That's purely on an informatics point and business point of view. So there's a risk in sharing accounts on that side as well. But I think people just need to look at what could people do, what makes sense, does it violate any regulations or business rules?
I see. And again, a couple more questions. So relating to rights, what right should a user have and at what level? I guess that's something that companies have to determine for themselves, but given your experiences, do you have any perspectives to share? As in, like, which folder should be secured? What level should it be secured at? Do you have any insights on that?
There's a couple of things that come out from the observations, and one is that very often there are far too many administrators in the system. And I think monitoring who has administrator access is the first place people should look at. Really, a true administrator, I'd call it the God-level administrator, should be restricted to very few people. However, normal administrative functions could be actioned by people in the laboratory, such as resetting passwords, who are trusted. So deciding who could have those kind of administrator privileges within the organization is something really a company needs to come down to. But it does need to be very clear in a document about who has that kind of access. The biggest concern that's come up with these recent issues is that everybody can delete data. And I think the next thing after controlling administrators is to go through users and be sure that nobody in the lab, not managers or anybody, is allowed to delete data of any kind. Even administrators really need to only be able to delete entire folders when they're archived. So deleting individual results, deleting individual methods is something I would be sure that very few people have access to be able to do that. And that's going to take you a long way to preventing risks of the kinds we've been talking about already. But when it gets down to other privileges, it really depends on what you have what processes you have in the laboratory. Who is allowed to approve somebody else's work? Who is allowed to change integration parameters? Who is allowed to change reports? Is something that every company needs to look at and decide, well, these are the people that are trusted and trained to do those functions. If I just prevent other people doing it, I'll prevent them doing it by mistake, even more so than doing it on purpose.
Got it. What would be the justification for manual integration? I know you talked about this issue, but how would you, if you had to do it, how would you justify it, I guess?
I had a very interesting conversation with a group of customers about this once, and we were brainstorming about why and when would you do manual integration. And clearly, if you've got good chromatographic separation, baseline resolved, an algorithm should be able to do that without an issue. But that's not ideal. That's not going to happen in every laboratory in every case. My belief is that actually manual integration is much more justifiable than very complex, detailed, eventful integration methods. And I've seen people create very creative integration methods to do what you could do in 2 seconds manually, much faster and probably more accurate. But because of a rule about no manual integration, they'd rather do the creative integration parameters than manual. I think the real justification that we came up with the customers was, why would I do manual integration? It's when a reasonably simple integration method is not doing the integration correctly. Ideally, if we had the time and the inclination, I think every chromatographer could accurately integrate everything by hand. We don't have that time. And as long as all the results are saved, and this is where there can be issues, if you don't save that manual integration that you can pull it up identically to how the analyst did it, then trying to avoid manual integration is critical. However, if those results are saved, including where the start and the peak ends were, so there's no concerns at all that it was not as you're looking at it when it was processed. Personally, I think the manual integration provides more accurate integration than automatic integration methods. It's a little controversial, and people do have their own views, I know, on that. But scientifically, I believe that whenever I've got non-baseline resolved peaks, I could probably integrate it more accurately by hand than by using a very sophisticated automated method.
Okay, good to know. Well, we are kind of running out of time, and the questions keep coming in. So let me try to get to maybe another one or two, and then unfortunately we will have to close out the discussion. But I wanted to remind people that the webinar will be archived on Lab Manager's website, and you will have access to that at least for a few months. Some people have asked whether we can present this webinar at a time that's convenient to the European and the Asian audience. I don't think we can do that, but the archive is always available. And more importantly, Heather, if you don't mind moving to the next slide, we have Heather's email address right there on your screen. So you can definitely follow up with her, if you have more questions or if you need a copy of the slides, because again, the slides cannot be downloaded from our website. And as you can hear, Heather has a lot of information, and she's a great resource for you to follow up with. So again, I think this would be the last question. So can you talk a little bit, Heather, about reporting method validation and custom fields? So are there any best practices there? For instance, this person uses, a development environment and then moves the report to QA for validation and then to production. So do you have any thoughts or ideas on how that can be done most efficiently?
Sure. I think that the approach that the questioner has put in is very useful. I think depending on the system that you're using, and they mentioned custom fields, so it sounds like it's in Power, but depending on the system, the report may have one or more functions in it. Some reports and some ways people build reports will have calculations in the reports, and if that's the case, absolutely validating the reports and locking those down is critical. In other cases, a report is simply a presentation of a portion of the data that's in the electronic record. And remember, the FDA says those reports are never going to replace the electronic record. They don't meet the predicate rule. We still need to look at the electronic record, and we still need to review the electronic record, and we still need to keep the electronic record. So the purpose of a report needs to be challenged sometimes. I've often spent a long time with customers designing a perfect report, and then I said, well, why don't you just log in and look at the data electronically instead of relying on this paper? That really seems to be the way the regulatory bodies are going. So you can lock down reports, and I think if you are going to be using them in any kind of view, they absolutely should be locked. I'm not sure that the term validation is the right one. I think control is probably more accurate, unless there are calculations that are being performed as part of the report. On the calculations, if you are doing personal calculations that are specific to your laboratory, just as if you were doing them in an Excel spreadsheet, you need to be sure that you put those calculations in correct and they give the right results. And a short validation of a particular calculation that you've built in yourself seems to me to make perfect sense to do that, but it doesn't need to be a 400-page validation report. Simply, these are the numbers, this is how I've built it, this is how it's designed to work, this is how it will error, and here are some test cases where I challenged, did I do it right? And then locking it to prevent further changes is probably what's mostly required. But the questioner sounds like they have a good control of that process.
Right. Well, that brings us to the end of our time, but thank you again, Heather, for a really, really nice presentation. Judging by the questions that came in, I think, people are very, very interested in this topic, and they have, a lot of questions that they need answered. So what we're going to do is we're going to try and forward all the questions on to you. If you can spare a few minutes to get back to the people, especially those whose questions we were not able to answer here in real time, I would appreciate if you can take a few minutes to get back to them. And thanks a lot for the talk, your time, and also for some candid answers to the questions that came in. So on behalf of Lab Manager, I would also thank Waters Corporation for their support of this event. This is really what made this discussion possible. And thank you all online for your time, attention, and for all your questions. This is what really makes a webinar very interactive and interesting. Again, a quick reminder, we will not be able to send slides to anybody. You will have to reach out directly to Heather via email and ask her for a copy of slides, or if you have additional questions for her. And please do check our website. We are constantly updating it with new information on upcoming webinar topics. And then there are also other webinars that we have done in the past that you may be interested in looking at. So until next time, everyone, goodbye and good luck.